Um, yes, again. So Rohan is a grade 7 boy. He is very quiet, but very smart boy. So whatever you try to teach him, he will learn, and he will never say that much, but he will do everything. So start, Rohan.
Um, okay, so my name's Rohan, and today I'm going to be talking about black holes, which are one of the most mysterious things in the whole universe. Actually, more than the universe, like all of space. So let's start off with what a black hole is. So a black hole is a region of space-time, which is basically a mixture of space and time. So a space-time is like a mathematical model that joins space and time into a single idea called a continuum. This four-dimensional continuum is known as Minkowski space. Gravity in a black hole is very strong that no particles or light or electromagnetic radiation can escape. When a star runs out of their fuel or nuclear fusion, it turns into a white dwarf, a neutron star, or a black hole. Of course, for a black hole, the star has to be really big, like we're talking about 10 to 15 times the size of our own sun. And since mass of the star is constant and the size is changing, the gravity intensifies and everything gets sucked in. So there are four types of black holes mainly. The first one is primordial, the second one is stellar, the third one is intermediate, and the fourth one is supermassive. Last year, if you can remember, there was like a huge hype on this black hole right here. It's a supermassive black hole at the center of the galaxy Messier 87, and it's around a black hole. There's a position of no return, which is called the event horizon. And this event horizon, if you get trapped in it, there's basically no way of escaping because you'll have to move way faster than the speed of light, and that's pretty much not possible yet. And there's one supermassive black hole at the center of our galaxy called Sagittarius A, and we're right here. We're like on the right hand right hand corner, like bottom corner of the Milky Way, but this is in the middle. So how does a black hole form? A black hole forms from a star. Stars are basically massive collections of hydrogen atoms that collapsed from gas clouds under their own gravity. In the core, nuclear fission crushes hydrogen atoms into helium atoms, releasing lots of energy. But for stars bigger than our sun, the fusion goes on further and it reaches iron, and that's how a black hole forms. So here you can see it goes from hydrogen, helium, carbon, neon, oxygen, silicon, and then finally iron. And then iron can't fuse, so it builds in the core, and the balance between fusion and gravity is broken. And if that's broken, the star explodes into a supernova explosion and implodes, feeding in the mass of the core into the center of the star. And this forms a neutron star, or if the star is massive enough, a black hole. So I'm gonna talk about like brief history of like black hole physics and how we discovered black holes. So first, it all started with Albert Einstein. You all probably know him. His his first major discovery was the theory of general relativity, which observed gravitational effect between masses of matter due to warping of space-time. Well, in like simple English, that means that time is not like a constant; it's actually relative to where you are. Sure, you could see that two people, one in like a UFO and one in on the ground. And the one in the UFO has base off, and the one on the ground also has the same thing, and they're synced. But there's also a guy falling from the sky, and the people here are observing his clock going in like triangular motion, basically. Then in 1916, 1 year after, Karl Schwarzschild, a German physicist, found that any mass can actually turn into a black hole if it were compressed tightly enough. He also found the Schwarzschild radius, which finding like the area of the black hole. So in this equation, radius equals 2 times the gravitational constant times the mass over the speed of light squared. And then in 1971, a long time after, there was the first sighting of black holes. Like technically it wasn't sighting because black holes were still invisible at that point. So it was done by this guy named K.Y. Low, and he was studying the constellation Cygnus, and he discovered the first black hole by seeing its effect on like closer objects and things that it radiated. So initially he was looking at star formations in the constellation, but then he saw that there was a disruption to the objects in the constellation, and so he tried to see what was there, and he found a black hole. But the term black hole was actually coined in 1969. So next in 1972, there was Stephen Hawking. We all know who Stephen Hawking is. He found out that black holes emit Hawking radiation. So space is not really like empty space. It actually has like pairs of antimatter and matter, and once they appear, they incinerate themselves. But at the exact edge of the event horizon, one of the particles get sucked into the black hole, so we're left with an antimatter pair. So this is called Hawking radiation. So here are some other events which are not, they're like more recent. So astronomers found accretion disks, which is like the orangey yellow around the coal we photographed. And in 2002, Max Planck Institute of Extraterrestrial Physics found Sagittarius A, which is the black hole in the center of our galaxy. And in 2006, Event Horizon Telescope was set out to find the details about these mysterious objects, obviously because of its name, Event Horizon. And then in 2019, last year, the first black hole was photographed by the Event Horizon Telescope, 13 years after being sent out to gather data. So this is just the image of where the satellites are for the Event Horizon Telescope. So there's like a bunch like in Greenland, Arizona, Hawaii, Mexico, France, Spain, Chile, and in the South Pole. So there are 4 types of black holes, as I mentioned earlier. The primordial black holes, these are actually theoretical. They were born really early in the life of the universe, less than a second after the Big Bang, or however you believe the universe was created. And it was a long time before stars or galaxies could exist. So some theories predict that primordial black holes existed before the Big Bang, because before the Big Bang, space was not completely homogeneous. It was denser, hotter in some areas. So that could have collapsed into primordial black holes. And these are actually very small, as you can see here. And then the next is stellar and intermediate black holes. So both of these are 5 to 10 times the size of our sun. Stellar black holes are formed by the normal process, while intermediate black holes can form from many things like black holes colliding. And these black holes are the standard size for black holes. Like they're like the common size, kind of like in the middle. And then the last one is the biggest ones, which are supermassive black holes. These black holes are like millions to billions times the size of our sun. and they exist in the center at about every large galaxy. So this is the closest universe to us, which is called the Canis Major Dwarf universe. And then this is the Andromeda galaxy, and this is our own galaxy. And as you can see, there's a black hole in every single one of them. And the Sagittarius A, the one right here in our galaxy, is actually in the center. Actually has the mass of 4 million suns, and it has the diameter of the distance between the Earth and the Sun. So that's like really big. So can black holes die? This is a highlighted top. So that I want to say this today. So black holes are always radiating their energy. So what this is called is Hawking radiation, as I mentioned earlier. And Hawking radiation was found by Stephen Hawking. And so black holes lose small particles of mass, and this is a really slow process. It will, like, scientists predict that it will take like a Google years for black holes to die, which is like 1 followed by 100 zeros. So it's like a long time. And long after everything, including humans and stars, die, they will evaporate and leave behind a little radiation. So this is like a thing of how it will die. So what would happen if you get sucked into the event horizon? So you'd be pulled apart by the immense force of gravity. You'd be spaghettified inside to become a string of subatomic particles. If you somehow manage to survive, time will go really slow because the gravity is so strong. And time pretty much stops, as in the activity. And you would fall into the black hole singularity, which is infinitely small, infinitely dense point where space, time, and the laws of physics don't really apply. So, have any of you watched the movie Interstellar? So in Interstellar, they land on a different planet, and 1 hour is actually 7 years on Earth. So this is like kind of a problem for the astronauts, because like they want to see like their children before like they die, so they don't want to spend that much time on it. So this portrays like the theory of general relativity, and this is basically what would happen if you get sucked into a black hole. And this showed viewers that this time is not like a constant; it's actually relative to where you are. And the protagonist comes back, and his daughter is like very old, like she's on like her deathbed.
Is it on Netflix?
Yeah, it was.
Yes.
It was on, but I don't know now. Okay, Deb.
I'm pretty sure it is.
Deb.
Oh.
Yeah.
Did you do you know that Interstellar in the Netflix yet or not?
I'm not sure. I can check.
Okay, not now. Okay, go. You, Pritul, it was there, but we will see. Continue. Pritul, go on to video. Pritul, go on to video. Everyone is on video. Okay, go.
So there are some challenges to like detecting black holes. That's why we didn't have like a photograph of black holes until like last year. So probes can't be sent in because they would lose connection. Humans would for act on nearby matter. This includes what is called a accretion disk. And so an accretion disk is like the black hole sucking in a bunch of light, and it's like gas and dust and also light. And there's also quasars, which like jets of particles that blast out of supermassive black holes. And we also detect black holes with these. And in the picture of the black hole in 29, the accretion disk is the glowing ring around the supermassive black hole. So now I'm going to talk about future research on black holes because they're pretty still mysterious. We just got a photograph of them. So a lot of research has been done about black holes, still being done. Questions are still unanswered, like what really is inside a black hole, or are black holes like portals to another dimension? called a wormhole. Hopefully, of this mysterious object in space. Does anybody have any questions?
Are you done? Yes. So thank you very much, Rohan. You are kind of next Einstein, I am sure. You know a lots of things and very difficult things. These are the very critical things, difficult to explain. Mathematics can say lots of things. So do you know that the image of 2019, this black hole, how they made?
Yeah. So basically, they had a bunch of cells, and the orange ring around it, the orange ring around it. So they saw that, found it.
Okay, anyway, your network is very bad. So you are sitting into kind of out of Toronto. So there's lots of interruption in your presentation, but it is really, really great scientific presentation. Lots of information we need to know. Physicist does not know even.
Yeah.
However, the color you have seen, it is not lighting like that. It was detected by not the light spectrum. It is lower than light spectrum. Okay.
Oh, okay.
Anyway, so anyone has any question? It was very difficult subject he presented. Any question?
I have a question.
Yes, yes. Not only you, Pitul, you need to be ready, Pitul. Okay, Smita.
I learned in school that black holes, like they were like nothing or something like that.
No, I said that they were like, you can't see them, but they're not nothing. They're like infinitely
So-
dense.
How can you see them if you can't? How do you take a photograph of them if you can't
Boom,
see them?
good question. Yeah.
So like I said before, like the light, there's like light propulsion out of the center of the black hole, which is called a quasar. And that's how we first detected that there was a black hole there. And also you could see, it's pretty obvious because the gravity is so intense there. You could see like how other objects nearby affect are affected by the black hole.
Good.
Yeah.
Dave, you have any question?
No, no questions.
Okay, so Pitul, you need to ask some question. No,
No, I don't.
you don't. So do you know that lots of difficult thing he explained? Did you understand everything? Okay, so we are going to end this session. Then what else? Dave, should we continue for you? We 2, 3 people are still remaining. You, Pitul, and
Yeah, I can
Smita.
present today. It's not that long.
You want to?
Yeah, sure.
Okay, then we will finish. 1 minute. We reset.